Okay, a formal good evening to all of you. So as you can see, the question is given here. So it is d square x by dt square, that is missing here, plus pi square x is equal to 0, x is the displacement. So the frequency in oscillation. Quite a simple problem. Please solve it. So like it's just like a warm-up question to all of you, and everybody should solve. And those of you who have solved, please tell the answer. I mean, tell me that you have solved it.
Yes, sir.
Yes, Aryan has done, because Aryan is a good boy who does the homework well and comes to the class. As usual. So Aryan, what is the answer?
1/2.
1 by 2. Okay. So I'm sure Aryan would have substituted. I mean, this is a quite a simple problem. So, by inspection you can write out, because
Yes, sir.
the final expression for this is going to be, so it is of the form d square x by dt square plus omega square x is equal to 0. So here instead of omega square you have put pi square. Okay, and omega is 2 pi f whole square. So therefore, straight away the pi's get cancelled, and you will have f is equal to what? The pi's will get cancelled. You will have 1 by 2. So that is the answer. Yeah, some of you will not answer. I don't know whatever be the reason. Okay, this was just a loosener, I can tell you. Now go with this. Aram say. So try to brush up the theory. I am sure you would have brushed up and come to the class. All of you take interest and Aram says all this. The rotating phasor concept, if you use, then you can solve it by science and logic. But if you are familiar with using the equations also, you can do. Anyone?
Yes.
Yeah, what's the answer? I am not getting you. Please shout the answer.
Option B.
You got option B. I don't know the answer. I have also got to solve this. I was out of station today. I just came back. I left the home at 5 o'clock in the morning and came back at 5 o'clock. So I have not looked at it. So anybody else?
Option C.
Option C. Anybody else?
Sir, even I think it's option C.
So 2 students are putting it as option C. Okay, then I will ask these 2 students. Okay, Arun, begin. How did you get option C?
Sir, I drew phasor diagram.
You drew the phasor diagram. Okay, now let me draw the phasor diagram. Help me. Tell me, what should I do?
Sir, consider one circle. Sir.
Consider one circle. Okay.
That will be the phasor, and draw the coordinate axis at the center, sir.
You want me to draw the coordinate axis and the center?
For angles, it will be easier, sir. That's why.
Okay.
From the center, sir, you draw a phasor, that rotating vector you draw, sir, at certain angle. Then on the opposite side, like you take mirror image of that with respect to this y-axis and draw that, sir. So if we consider the first case, it has displaced towards it is moving towards positive x-axis. That is why we have considered it in first quadrant. In the second case, it is moving towards negative x-axis. That is why we have considered the second quadrant.
It is moving towards negative axis.
Yeah, negative x-axis. In that arrow is on the left hand side, no sir, below the block.
No. This is for the, see, these two arrows are to indicate the dimension. These arrows. This arrow is indicating the direction. This arrow is indicating the direction.
Okay, sir. I think then I made a mistake.
Okay, you correct it. Mr. Arun?
Yes.
You did you also do the same mistake? Commit the same mistake?
Yes.
Okay, now come out with your solution. How did you get the C?
Sure. The first quadrant diagram is correct, sir.
Okay.
The second quadrant is not. You are.
The second quadrant is not right.
Yes.
Right. The first quadrant diagram is right. Second quadrant, what should I do? Second diagram. What
Next result will be in the fourth quadrant.
Fourth quadrant. Okay.
So since the displacement is 0.5 amplitude, so first angle will be pi by 3.
This will be pi by 3. Okay. Pi by 3.
No, pi by 6.
Pi by 6.
Pi by 6.
Pi by 6.
For the second one it will be pi plus pi by 6.
Second one, it is going to be
3 pi by 2 plus pi by 6.
3 pi by 2
Plus pi by 6.
plus pi by 6. Then you have found out the difference between the two. Correct? Hello? Hello? Then you have found the difference between the two?
So it is 3 pi by 2 plus pi by 3.
This will be 3. This will be by 3 pi by 2 plus pi by 3, yeah?
Yes. Then only get 5 by 3 pi.
So you have taken this and subtracted this with this.
Yes, sir.
And then you got this answer.
Yes, sir.
Hello? Yeah, your procedure is correct. I have not checked the plus and minus there.
Sure.
But
I also wrote 0 by 0 minus.
yeah, your procedure is correct. Why? Because, okay, see, you have taken the function here as x is equal to x is equal to a sine of omega t. You have taken this as the waveform, right? Right.
Yes, sir.
And therefore, the first thing that you have done is correct because this will give you positive 0.5a, and for this it is going to give you negative 0.5a. So whatever you have drawn is perfectly correct. And the other important thing is, well, you have taken the arrows properly, both of them going to the right, and obviously, so the quadrants you have chosen is also correct. So the procedure you have followed is perfectly correct, and then you have written these values, that is also perfectly correct. So then this minus this is going to give, is it going to give you this? Others, please check.
Yes, sir.
Okay, then this option is the right. Correct. Yes, others, did you understand this?
Yes, sir.
If you have not understood, then I can explain this to you. I am sure you would have all understood this. Anyways, you see, when you take this function, when you first say, well, you know, I am going to consider the waveform of the oscillation is like this. It's not a wave.
Actually, on subtraction, I think you get 11 pi by 6.
That's what I said. You only told it is correct, sir. You are the one who substantiated it.
11 pi by 6.
Are you getting 11 pi by 6? ನೋಡಪ್ಪ ಇದೆಲ್ಲ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಬಾರ್ದು ನನಗೆ. ನೀವು you only told it is correct. Why did you tell it is correct? So now I have to check it out.
5 by 3 times.
5 by
3 times.
It is correct now? I think it is correct. Option also says it is C only, it should be correct. Mr. Abhinav, you check it out. Now you should take it, even Aryan said well, that is correct, so it is correct. So if you have considered the waveform of this type, x is equal to 0, so then this becomes plus A axis, amplitude axis, this becomes minus amplitude axis. Okay, so that's how you have to demarcate it. So whatever values you get here are plus, that means it is to the right of this. If the body is to the right of this axis, then you will get it in this quadrant. If the body is to the left, you will get it here. Well, if the body is moving like this, then it will come in this quadrant. If the body was moving like this, then you would have written it in this quadrant, so and so forth. And again, if the arrow was in this direction, the body was moving in this direction, then you would have taken in this direction. So everything is perfectly correct. So we have got the right answer. Done. Very well. Well done. Shall we move on, students?
Yes, sir.
Yes.
You should try to solve these equations by inspection. So try to aram se look at that, understand it. Look at the graph, correlate the options.
Yes.
What is the option?
C.
C only. What about others? No, it should be C. How did you get it?
Sir, initially it is at the wave is beginning at 5, sir, which is 10 by 2, sir. Which is half of the amplitude, sir, so it will be sine by 2, sir.
So if you substitute, that is at time t is equal to 0, the value of the amplitude is the value of the signal, or the value of the signal that they have done here should be 50% of the amplitude. So you will get, so if you put t is equal to 0, then it should be 10 sine pi by 6, gives you 50% of the amplitude. So option C is the right one. That's it. It is quite simple. By visual inspection you can have. Pardon?
The option B, sir. That P means pi and just P.
That's what. What is that P that they have given there? They have given some P in general. So that's not the thing. Okay?
Yes, sir.
Clear? By inspection you could have done this.
Yes.
The phasor technique you can again use. If you are comfortable with the mathematical model, you can do it. It's up to you. Arun seems to be very smart. Some days you are very, very sharp. Some days you are very dull, moody. Okay, he is saying B, but others also please work it out. Maybe right, maybe wrong, I don't know. When they are going in the opposite direction, they pass
2 pi by 3, sir.
2 pi by 3. What is the option here? You tell in terms of option.
Yes, D, I think.
Huh?
D.
Pardon?
D. Yes, sir.
What about some others?
Yes, automatic.
Well, again, the same logic could be used here. So, I think again consider the phasor. So, they have told they pass through the same point, but they are going in opposite direction. So, that means now if you have taken the first particle A to be in this direction, the second particle which is passing through the same point means the displacement must be C. Correct? So again, you have considered here x is equal to a sine omega t, right? So the second particle must be here. Correct? Hello? Should be there because see the displacement is C, right? So if you take this as theta, this should also be theta, and the displacements are same. Only thing is, as you told, as we have seen earlier, this is going in this direction, and this particle must be going in the opposite direction, but both of them are at the same position. Hello, correct?
Yes, sir.
So as you feel they pass with opposite direction each time, and the displacement is half. Half means this theta must be pi by 6. Okay, so pi by 6, that is 30 degrees, 60 degrees, and therefore this must be 120 degrees. So these are the directions. Hello, got it?
Excellent.
Simple, very simple. These are simple problems, try to solve it quickly. What is the option?
Option D.
Somebody is reading D. Others also try, please.
Yes, sir. It is.
Okay, fine. So it's quite a simple problem. Amplitude is a period is t. So that means its displacement at a time t by 4. So if you have taken this as t is equal to 0, then this will be t by 4, correct? So t by 2 will exactly be this. The time here will be t by 8, and this is going in this direction. This is the time, so this has to be 45. So the amplitude here, well, you can take either cos or sine, both are same. The amplitude here would be the thing here is this will be a cos of 45, so that is a by root. So this is the right option, correct? Okay, done. Fine, student, shall we go ahead?
Yes, sir.
Yes.
Be careful when problems like this are given, then there cannot be one solution. It is better that you go mathematical here. It's better you go mathematical here, because mathematics gives you the sure answer. Almost it will come closer to the truth. Logic is good, but sometimes logic can fail. But mathematics, the mathematical modeling will not fail. The greatest distance between them. So now you have to take two equations for two particles. There is no other go, you have to take these two. Hello?
Yes.
Correct? So the second step, whatever they have given here, you have to take their maximum distance, that is x1 difference x2 modulus, that gives you the maximum distance, and that well, in terms of equation you've got to write this. So this they have told is equal to 3a by 2, and this is x1 difference x2. So this becomes a into sine of omega t minus sine of omega t plus phi. So sine of a plus b, a by You know, I hope you know how to handle this. We'll open this up. No, if you are solved by logic, I will not accept. You should go with the mathematical model and solve.
So we can use resistance.
No, that's what I cautioned you. See, in such type of problems, don't go with logic. You okay? If you got A by 2 by logic, fine, but you verify it by mathematical model before you mark the answer. Okay, can you simplify this? Hello? Why did you take so much time? Come on, tell me fast. So this is, you are going to write it as what? Sin A minus sin B, you are going to write it as sin A plus B by 2 minus sin
2 cos A plus B
tell me.
by 2 sin A.
2
Cos A plus B by 2 sin A.
cos A plus B by 2 into
Sin A.
sin A minus B by 2. Correct? No? Now you go with this. Substitute the values here. So 2 cos A plus B. So you have to add A plus B here. So if you add A plus
2 times omega t plus 5 or omega t plus 5 by 2.
So you will get cos of
Omega t plus 5 by 2.
omega t plus 5 by 2. Okay? And sin A minus B, sin
Minus 5.
minus 5 by 2. Then, what is the next course of action? Students, you have simplified it till this point. Now just apply the logic. What are they told? What are they told here? See. Okay, now let me rub this up. Okay, now simply do this. Okay, simply do this. Hello? Hello, are you with me?
Yes, sir. Yes.
So you have simplified it to this point. Now,
Yes.
what is the maximum value of this? The maximum value of this is this, see, because t is a variable here, t can keep varying at a particular instant of time t, this quantity, cost quantity can become 1. Correct?
Yes, sir. Yes, sir.
And then the maximum value will be what? 2a sine of 5 by 2. Correct?
Minus 2a.
See, listen, you think, man, you also think, don't simply keep telling like that. I told modulus of this, modulus means only the magnitude.
Okay, sir.
Hello, are you with me, all of you? See, I have written here the difference here. I have simply written the whatever we have assumed, correct? And then you only simplified it. You got this value, correct? Okay, I'll keep writing the modulus. You only simplified it, correct now? Then for this expression, what is the maximum value? The maximum value will be, that is, when at particular instant of time t, the cos function can have the maximum value 1, correct?
Yes, sir.
So the maximum value of this expression will be 2a sine phi by 2, and this is equal to 3 by 2a. Clear? That is what they have.
Yes, sir.
Hello, everyone there?
Yes.
See, this is where, see, this is what I am trying to tell you. For such problems, write the math model, analyze it, right? So now, quickly you can analyze this, and what is that you get here from this?
Sine phi by 2 equal to 3 by 2.
So you get here sine phi by 2 is equal to what? 3 by 4. This expression you got. Correct? Okay. Now we will take the second condition that they have given and proceed. Now proceed.
Yes, sir.
Now you did again?
Yes, sir.
Good. So now the second condition they have given is, at some instant of time they might have a displacement from, at some instant they have the same displacement from mean position. The same displacement from mean position. That is, at some instant of time t, you will get a condition x1 is equal to x2. Correct?
Yes.
That means now sine of omega t, what we have assumed, is equal to sine of omega t plus phi. Clear? Hello?
Yes.
So now, well, again you have to do a bit of analysis. When this is equal to this, then I think there is some relation between this. Sorry, I have not written E. Of time they have same displacement. See, just now previous problem we have done. Now you use phasor diagram and logic.
We have general solution in math.
No. See, when I am telling you to use logic, you will go for general solution. Now you use logic. See, we have seen now here. See here. See now in oscillations. What is a sine omega t? Supposing this is making some angle theta. This value is what? A sine omega t. Correct? Hello.
Yes.
And this should be equal to a sine omega t plus phi. Plus phi. One second. I'm just telling you. So when we had some situation where the displacements were same, then these two angles were same. Correct?
Yes.
These two angles were same. Okay. So in this case, just give a thought process to that. Instead of theta, we have got this value. Instead of theta, we have got this value. Correct? Hello? Okay. So therefore now, see, whatever it is, this angle between these two, this angle. What will be this angle? This angle will be pi minus theta. Correct? Sorry, this angle. This angle will be pi minus theta, no?
Yes, sir.
No, this angle.
Okay.
This angle will be pi minus theta, correct?
Yes.
So now, you see, whether can we make use of that thing here and then equate the two, that side, this side. I am giving you enough hints. Come on, take it and work.
Sir, that distance that we have got earlier, 2a cos omega t plus pi by 2 and sine minus pi by 2, sir, that one can't be equated to 0? Because if they are at the same position, then difference will be 0.
See, you read the question carefully. You read the question carefully. Both the phasors are rotating, and some position, their maximum distance they have given, for that they have written the condition. Then they have told at some instant of time. At some instant of time, they have. See, listen, at some instant of time. See, when we wrote that equation, we have to use the modulus. That means we have only considered the distance between them. But here it is displacement. Now watch out. So you cannot listen. You think I am giving you the hint. I am giving you the hint. Here displacements we have to use, distance also we have to use. Under what context we have to use? You think. Now don't deviate. We are closing into the solution. Now, Mr. Abhinav, please concentrate here. So you see, this is how we used to get. See, you take the track away. When I am discussing this, you are going there. Please don't do that. So this is theta, this is theta. So now instead of theta, we have got omega t plus 5. So now see here, this and this. How can you get this? How can you equate these two? Because now this and this we have got to equate. But definitely you cannot say omega t is equal to omega t plus 5. That is not possible. Okay, there is some other angle where this expression will hold good. There is some other angle where this expression will hold good. See, both the sine functions must be same. So that is sine pi minus something. Correct now? Hello?
Yes.
So take that hint. So therefore, what if I write sine of pi minus omega t? I can equate this as a sine of omega t plus 5. I think this is perfectly mathematical. Hello? Correct now? See, they are told at some instant of time, I have to grab this t. At some instant of time t. See, mathematically this is correct or not, you tell me.
Yes.
So now you can equate this, correct? Now you can equate this. Hello?
Yes.
Please do that. Please do that now. So you get here what?
Omega t is equal to pi minus 5.
Omega t is equal to pi
minus 5.
Pi
Minus 5 whole by 2.
Whole by 2. That is pi by 2, pi by 2. Correct?
Yes.
Right. So omega t is equal to this, is equal to this. Okay? Now, so till this point I have helped you to solve.
We have to substitute this omega t in the.
We can use 5 from the previous equation.
Yes, and substitute it there. Correct?
Yes.
Then you will get to know what is
We
the.
will get directly value of omega t, sir. And x will be s.
Yes, at some instant of time, this is equal to so and so. So you have got the value of omega t here, and I think in this expression you have got to substitute that. That's it.
Yes.
We have got to get the instant of time. That's it. So take it down. X1 is equal to what?
Can we take sine conversion?
Take it sine omega t only. So sine of a sine omega t. So put it there. A is equal to A into sine of omega t is what? Pi by 2 minus pi by 2. Because we want instant of time, that's it. So this becomes what? A cos of pi by 2. Correct? Hello? Correct now?
Yes.
So they are asking the instant of time, no?
Sir,
What is the display? At some instant of time, sorry, I pushed it this way.
you know the
At some instant of time, they have same displacement. What is the displacement? They are asking you what is the displacement. What is the displacement? Either you find out x1 or you find out x2. One of them you find out. I am finding out x1 here. So it is cos pi by 2. Now we know what is sin pi by 2. We got it now. Sin pi by 2 is 3 by 4.
Yes.
So that is sin minus pi by 2.
Arey yaar, we have taken modulus there. We have taken modulus.
Yes, sir.
We have taken modulus, correct no?
Yes, sir.
So what we had got there 3 by 4. What we had got earlier was sin pi by 2 is 3 by 4. Okay, I'll just substitute that. So it will get a into root of 1 minus sin square pi by 2. So this gives you a into 1 minus 9 by 16. Right? So that gives you a root 7 by 4. Okay? So this is x1 and x1 is equal to x2. So this is the minimum displacement when minimum displacement when both the displacements are same. Okay? We have this expression here. Yes. We have got an option B. It is like this. Right? Hello?
Yes, sir.
So let me check the option. For which sum is this? Sixth one. Sixth one. Yes. B is the option. See, this is a beautiful sum. Got it? See, here this difference. I hope all of you understand the solution here.
Yes.
Great problem. See, that's what I said. See, when it's in such cases, you write the math model. Okay? And then go about solving it. It's a wonderful problem. Well, shall I proceed?
Yes.
So with logic, if you can get hold of the problem, get hold. Okay, but then be careful whether that is the solution or no. Then you have to go in for the math model. Or if the logic you are very sure that that is the right answer, you can go ahead. Mr. Arun, you had got answer A by 2, right?
Yes, sir.
Now you know where you have done mistake, where was the mistake. So that
Yes.
see that's what I am giving you some hints how to look at the problem, where to use logic, where you have to use this. You cannot be pretty sure with the logic, especially when things like that, the greatest, shortest distance, you have got to be careful. Because the vectors could be positioned anywhere to get the shortest distance. Okay, now get hold of this problem. What happened? Logic. Yeah. Arun, what happened to you?
Still done. Option C.
You got option C.
Yes.
Okay.
Phasor with amplitude 5.
So they have told it's a phasor with amplitude 5 and shortest time taken for x is equal to 4. So if you take the waveform as x is equal to a sine of omega t, then mark the position x is equal to 4. This is x is equal to 4 and this is x is equal to minus 3. Correct?
Yes.
So the corresponding phasor for this, the corresponding phasor can be like this also, can be like this also. And for this, again, it can be like this also, it can be like this also. So their thing is, they have got the shortest time taken by this. So you have to calculate this one. Delta.
Yes.
This is the shortest time. That's it. Okay? And they have told the amplitude is 5. The amplitude is 5 and this distance is 4. Isn't it? So obviously this should be 3. This anyway they have given it is 3. So therefore this should be how much? This should be 37 degrees. Correct? Hello?
Yes.
And this should be 53 degrees. So therefore this should be 90 degrees.
90. Even.
This also should be 90. Okay, so if this is 90, then the time period will be t by 4. So if it is 20 seconds divided by 4 will give you 5 seconds. That is the option. So it will take 5 seconds to go from here. Because the time period is t, so for 90 degrees it will be 5 seconds. Yes, that's the option. So here you see, you can use the see that's it. You know, just read the problem. Okay, these are the possibilities. These are the only possibilities. So, and they said shortest distance. Just wait. Okay, friends.
Yes.
Okay, friends. We'll continue. The particle is performing SHM is found to be in equilibrium at t is equal to 1 second and is found to have a speed of so and so at t is equal to 2 seconds. Calculate the amplitude of oscillation. Yes, you have to use math model and handle this problem. Well, you have no other choice, just to write the first starting equation. Then everything will come automatically. Write this expression and now use the conditions. At t is equal to 1, it is found to have is at equilibrium at t is equal to 1. So equilibrium position with the expression that they have given, we have to take x is equal to 0. So this gives you a sine of omega plus t is equal to 1 second. So this implies what? phi is equal to minus omega. So this is the conclusion that you can draw, right? So the first condition that they have given, and then they have spoken about speed. So differentiate this. So if you differentiate, you get it as a omega cos of omega t plus phi, right? And this they have told is 0.25 meters per second. So 0.25 meters per second is 1 by 4. Okay. So this is in general. So this will be 1 by 4 into A, and omega just now, omega is omega cos of omega t, and t is 1 second. T is equal to 2 seconds. Correct? Plus phi, we just know what it is, minus omega. So please. So that A omega cos of 2 omega is cos of omega. One by 4. So they put amplitude of oscillation. What is condition? Period of oscillation. So that means 1 by 4 omega is 2 pi by t, 6 into cos of 2 pi by 6. So 2 pi by 6 will give you pi by 3. So pi by 3 is half. So that gives you 6 will come in the numerator, and well, this will give you half, so 2 goes. So here you get 4. Okay, so you get here 2, 3 by 2. 3 by 2 pi. 8, 3 by 2 pi meters. Did you all get the same answer, students?
Yes, sir.
Yes, sir.
Yes. So A is the right option. This is quite simple. You know, you only have to understand the terms of terminologies and then proceed. Okay, it's a good problem to work. Okay?
Yes.